Assalamualaikum warahmatullahi wabarakatuh. Hello guys, welcome back with me. In this video, I wanna explain about technology in the future. Before that, I wanna spoiler. Maybe this video will bored for it because this video is 1 hour. So let's check this out. So in here have 10 technologies that will transform the global economy in 2025. With so many technologies emerging on so many fronts, it's a challenge to keep up. Every advance is built as the next big thing. Combining a report by the McKinsey Global Institute and knowledge of parasites subject matter experts, we have complete a list of 10 technologies that will lead the fourth industrial revolution. As the institute notes, not every emerging technology will alter the business or social landscape, but some truly do have the potential to disrupt the status quo, alter the way people live and work, and rearrange value pools. So, first technology is mobile internet. Interface, formats, sensors, and apps will evolve as mobile computing device dominates internet connectivity. By 2025, mobile connectivity could be accessed by an traditional 4.3 billion people. So, what is mobile data? Mobile data is internet content delivered to mobile devices such as smartphones and tablets over a wireless cellular connection. Mobile data plans over varying amounts of data transfer per month for a range of rates. When users email, access web page, or use mobile apps, their devices receive and transmit data from the internet. In the absence of a local Wi-Fi connection, a mobile device usually connects via a subscription service with a cellular network provider. Consumers and business users often think to the meaning of mobile data in terms of cost and usage because mobile data is measured separately from voice calls and can increase monthly bills. The increase in mobile users and the number of devices they own, as well as popularity of high bandwidth applications such as streaming video and video conferencing, excusing the amount of mobile data consumed every year to climb. Telecommunications company Ericsson's annual mobility report, published in June 2021, estimate the monthly amount of global mobile data traffic at 49 exabytes. The report predicts that number will exert to 237 exabytes per month in 2026. Mobile data versus Wi-Fi. A mobile data plan and a Wi-Fi connection both enable a user to access internet resources without a wired connection. Wi-Fi refers to a wireless local area network which has a limited range. When a user when a user connects to Wi-Fi, their device accesses a wireless router or access point covering a specific area. A mobile data connection enables a user to access the same internet resources over a cellular network owned by a telecommunication provider such as Verizon or AT&T. In this case, the mobile device connections to a cell tower that is part of a network spanning a very large geographic area. Well, will this access offers con- convenience and flexibility. It comes with a cost per gigabyte of data transfer according to the terms and policies of the user's cellular plan. How does mobile data work? Mobile data creates a wireless connection by enabling the device to communicate through radio frequencies. The data upload or download via a mobile network is broadcasted from or to a central cellular base station or microcell, often housed on a cell tower. A single microcell can cover a broad geographical location, and multiple cells can overlap to transmit data effectively and ensure coverage across thousands of miles. Cellular providers have offered mobile data through a number of different technologies incorporated to a progression of mobile networks identified by generation. The history of mobile data networks include the following. First generation or 1G. 1G transmit voice over cellular networks using analog telecommunication standards first introduced in 1979 and into the 1980s. 1G networks did not transmit mobile data. Second generation or 2G. 2G introduced digital voice in early 1990s, using in widespread data communication. Most 2G networks use Global System for Mobile Communication or GSM, based on code division multiple access (CDMI) for transmission. But as technology evolved, General Packet Radio Service or Enhanced Data Rates for GSM evolution were also adopted. 2G technologies 2G technology allowed mobile providers to begin offering text messaging and multimedia transmission using short message service and media message service. Third generation or 3G networks. 3G networks will first deployed in early 2000s, offer much higher speeds and bandwidth than previous generation. Based on the CDMI 2000 family of standards, 3G implement a universal mobile telecommunication service and high-speed packet access for better performance. These technologies were able to support video calling and the diverse applications that modern smartphones made popular. Fourth generation or 4G LTE. In the 2010s, 4G replaced 3G as the newest iteration of cellular technology. 4G transmission use multiple input, multiple output, and orthogonal frequency diffusion multiplexing technology. Some networks were called 4G LTE because they incorporate long-term evolution (LTE) in technology developed to help easy the transition from 3G to 4G. 4G network advantages including improved cell density, voice over IP capabilities, and bandwidth. Fifth generation or 5G refers to cellular network technology being rolled out in the 2020s. These networks are built on a foundation of 4G LTE but use a system of small cell stations rather than large cell towers to support the explosion of connected device and expand coverage and speed. Other benefits of 5G include low latency and real-time communication capabilities. Researchers are also working on 6G network technology, which will facilitate the growth of edge computing and the Internet of Things. So, next is mobile data use today. Upgrades to 5G networks will increase the overall availability and transmission rates for mobile data. 4G-enabled laptops and tablets will also be able to connect directly to the cellular network, removing the need for a Wi-Fi connection, so the amount of data an individual might use could increase drastically. The cost of that data is continuing to rise, making it important for customers and understand their usage and manage it where appropriate. Many everyday activities and apps use large amounts of mobile data and device and apps can burn data in the background when they are not even in use. Customers actively access mobile data when they browse the internet, listen to a podcast, or read email. But amount of data expended for common next is uh, technology is artificial intelligence. Machine learn. Wait a minute. Okay. Next is artificial intelligence. Machine learning and user interface such as speech and gesture recognition technology will advance to increase productivity or eliminate some knowledge work altogether. So, what is artificial intelligence or AI? Well, a number of definitions of artificial intelligence or AI have surfaced over the last few decades. John McCarthy offers the following definition in this 2004 paper or PDF. 106 kilobyte link resides outside EBM. It is the science and engineering of making intelligent machines, especially especially intelligent computer programs. Okay. It is related to the similar task of using computer and understand human intelligence, but wait, but AI doesn't have to confine itself to methods that are biological observable. However, decades before this definition, the birth of the artificial intelligence conversation was denoted by Alan Turing's similar work, Computing Machinery and Intelligence, which was published in 1950. In this paper, Turing, often referred to as the father of computer science, asked the following question: can machines think? From where? He offers a test now famously known as the Turing test. When a human interrogator would try to distinguish between a computer and human text response, well, this test has undergone much scrutiny since it's published. It remains an important part of the history of AI as well as an ongoing concept within philosophy as it utilizes ideas around linguistics. Stuart Russell and Peter Norvig then proceeded to publish become one of the leading textbooks in the study of AI. In it, they delve to four potential goals or definition of AI, which differentiates computer system on the basis of rationality and thinking versus acting. It is simplest from artificial intelligence as a field, which combines computer science and robust datasets. To enable problem solving, it also encompasses subfield of machine learning and deep learning, which are frequently mentioned in conjunction with artificial intelligence. These disciplines are composed of AI algorithm which seek to create expert systems which make prediction or classifications based on input data. Today, a lot of hype still surrounds AI development, which is expected of any new emerging technology in the market. As not in Gathering hype cycle, product innovation like self-driving cars and personal assistants follow a typical progression in innovation from over thousands to a period of delusionment to an eventual understanding to the innovation relevance and role in market or domain. As conversations emerge around the ethics of AI, we can begin to see the initial glimpse of the talk of the disillusionment. Types of artificial intelligence. Weak AI, also called narrow AI or artificial narrow intelligence or ANI, is AI trained to focus to perform specific tasks. Weak AI derives most of the AI that surrounds use today. Narrow may be a more accurate descriptor for this type of AI as it is anything but weak. It enables some very robust applications, such as Apple's Siri, Amazon Alexa, IBM Watson, and autonomous vehicles. Strong AI is made up of artificial general intelligence, or AG, and artificial super intelligence, or AC. Artificial general intelligence, or general AI, is a theoretical form of AI where a machine will have an intelligence equal to humans. It will have a self-aware consciousness that has the ability to solve problems, learn and plan for the future. Artificial superintelligence, or also known as superintelligence, will surpass the intelligence and ability of the human brain. Well, strong AI is still entirely uh, theoretical with no practical examples in use today. That doesn't mean AI researchers are, are, are not also exploring its development. In the meantime, the best example of AC may be from science fiction, such as HAL, the superhuman wrote computer assistant in 2001, a Space Odyssey. Deep learning versus machine learning. Science deep Since deep learning and machine learning tend to be used interchangeably, it's worth noting to nuances between the two. As mentioned above, both deep learning and machine learning are subfields of artificial intelligence, and deep learning is actually a subfield of machine learning. Deep learning is actually comprised of neural networks. Deep learning refers to a neural network composed of more than three layers, which will be inclusive of the input and the output. Can be considered a deep learning algorithm. This is generally represented using the following diagram. Diagram of deep neural network. The way of which deep learning and machine learning differ is how each algorithm learns. Deep learning automates much of the feature extraction piece of the process, eliminating some of the manual human intervention required and enabling the use of large data sets. You can think of deep learning as scalable machine learning, as Lex Friedman noted in Summit, a lecture uh, from above. Uh, Classical or non-deep machine learning is more dependent on human intervention to learn. Human experts determine the hierarchy of features to understand the difference between data inputs, usually requiring more structured data to learn. Artificial intelligence application. There are numerous real-world applications of AI systems today. Below are some of the most common examples: speech recognition. It is also known as automatic speech recognition, or ASR, computer speech recognition, or speech to text. And it is a capability which uses natural language process (NLP) to process human speech into a written format. Many mobile devices incorporate speech recognition into their system to conduct voice search. Example is Siri, or provide more accessibility around texting. Second is customer service. Online virtual agents are replacing human agents along the customer journey. They answer frequently asked questions or facts around topics like shipping or provide personalized advice. Cross-selling product or suggesting size or for users. Changing the way we think about customer engagement across websites and social media platforms. Examples including messaging bots on e-commerce sites via virtual agents, messaging apps such as Slack and Facebook Messenger, and tasks usually done by virtual assistant and voice assistant. Next is computer vision. This technology enables computers and systems to derive meaningful information from digital image, videos, and other visual inputs. And based on those inputs, it can take action. This ability to provide recommendations distinguishes it from image recognition tasks, powered by convolutional neural networks. Computer vision has applications within photo tagging in social media, radiology imaging in healthcare, and self-driving cars within the automotive industry. Next is recommendation engines. Using past consumption behavior data, AI algorithm can help to discover data trends that can be used to develop more effective cross-selling strategies. This is used to make relevant add-on recommendations to customers during the checkout process for online retailers. Next is automated stock trading. Designed to optimize stock port- portfolios, AI-driven high-frequency trading platforms make thousands or even millions of traders per day without human intervention. Next technology is virtual and augmented reality. Goldman Sachs is betting on the virtual and augmented reality industry to become an $80 billion market by 2025. It is around $7 billion right now. Major upgrades will come to technology infrastructure and an ecosystem of apps built for customers and enterprise alike. So, what is augmented reality? Augmented reality is one of the biggest technology trends right now, and it's only going to get bigger as AR-ready smartphones and other devices become more accessible around the world. AR let us see the real-life environment right in front of us. Trees swaying in the park, dogs chasing balls, kids playing soccer. With a digital augmentation overlaid on it. For examples, Mike Bison landing in the trash. The dogs could be mingling with their cartoon counterparts, and the kids could be seen kicking past an alien spacecraft on their way to score a goal. With advance in AR technology, these examples are not that different from what might already be available for your smartphone. Augmented reality is, in fact, readily available and being used in a myriad of ways, including as Snapchat lenses. In apps that help you find your car in a crowded parking lot, and infinity of shopping apps that let you try on clothes without even leaving home. Perhaps the most famous example of AR technology is the mobile app Pokemon Go, which was released in 2016 and quickly became an inescapable sensation. In the game, players locate and capture Pokemon characters that pop up in the real world on your sidewalk, in a fountain, even in your own bedroom. Next technology is cloud technology. Okay, one of the biggest buzzwords of the last decade will continue to impact the next. Nearly all IT service and web apps could be delivered through the cloud, with more enterprises using the public cloud as cybersecurity improves. So, what is cloud technology? Cloud technology or cloud sorry cloud technology or cloud computing is the delivery of on-demand computing service, from applications to storage and processing power, typical over the internet and on a pay-as-you-go basis. How does cloud computing work? Rather than owning their own computing infrastructure or data centers, companies can rent access to anything from application to storage from a cloud service provider. One benefit of using cloud computing services is the firms can avoid the upfront cost and complexity of owning and maintaining their own IT infrastructure, and instead simply pay for what they use when they use it. In turn, providers of cloud computing service can benefit from significant economies of scale by delivering the same service to a wide range of customers. What cloud computing services are available? Cloud computing services cover a vast range of options now, from the basics of storage, networking, and processing power to natural language processing and artificial intelligence, as well as standard office applications. Pretty much any service that doesn't require you to be physically close to the computer hardware that you are using can now be delivered via the cloud. What are examples of cloud computing? Cloud computing underpins a vast number of services that include customer service like Gmail or the cloud backup of the photos on your smartphone, to the service which allow large enterprises to host all their data and run all of their applications in the cloud. Netflix relies on cloud computing services to run its video streaming service and its other business system too. and have a number of other organizations. Cloud computing is becoming the default option for many apps. Software vendors are increasingly over their application as service over the internet rather than standalone products as they try to switch to a subscription model. However, there is a potential downside to cloud computing in that it can also introduce new costs and new risks for companies using it. Okay, so next technology is Internet of Things. More than 9 billion devices are currently connected to the internet. That number of estimate to grow between 50 billion to nearly 1 trillion in the next decade. Organizations will face monitoring and securing products, systems, devices, and even people. So, what is Internet of Things? Internet of Things, or IoT, describes the network of physical object things that are embedded with sensors, software, and other technology for the purpose of connecting and exchanging data with other devices and systems over the internet. These devices range from ordinary household objects to sophisticated industrial tools, with more than 7 billion connected IoT devices today. Experts are expecting this number to grow to 10 billion by 2020 and 22 billion by 2025. Oracle has a network of device partners. Why IoT is so important? Over the past few years, IoT has become one of the most important technologies of the 21st century. Now that we can connect everyday objects, kitchen appliances, cars, thermostats, baby monitors, to the internet via embedded service. Seamless communication is possible between people, processes, and things by means of low-cost computing. The cloud, big data, analytic, and mobile technologies, physical things can share and collect data with minimal human intervention. In this hyper-connected world, digital system can record, monitor, and adjust each interaction between connect things. The, the physical world meets meets the digital world, and they cooperate. Next, what technologies have made IoT possible? Well, the idea of IoT has been in existence for a long time. A collection of recent advances in a number of different technologies has made it practical. First, access to low-cost, low-power sensor technology. Affordable and reliable sensors are making IoT technology possible for more infrastructures. Next is connectivity. A host of network protocols for the Internet has made it easy to connect sensors to the cloud and to other things for efficient data transfer. Next is cloud computing platforms. The increase in the availability of cloud platforms enables both business and customers to access the infrastructure they need to scale up without actually having to manage it all. Next is machine learning and analytic. With advances in machine learning and analytic, along with access to freight and vast amount of data stored in the cloud, business can gather insight faster and more easily. The emergence of these light technologies continues to push the boundaries of IoT, and the data produced by IoT also fuels this technology. Last is convolutional artificial intelligence. Advanced neural networks have brought natural language process or NLP to IoT devices, such as digital personal assistant Alexa, Cortana, and Siri, and made them appealing, affordable, and viable for home use. What is industry IoT? Industrial IoT refers to the application of a lot of technology in industrial settings, especially with respect to instrumentation and control of sensors and devices with engaged cloud technologies. Refer to this Titan use case PDF for a good of recently industries have used machine to machine communication or M2M to active to achieve wireless automation and control. But with the emergence of cloud and allied technologies such as analytic and machine learning, industries can achieve a new automation layer and with it create new revenue and business models. Industrial IoT is sometimes called the fourth wave of the Industrial Revolution or Industrial 4.0. The following are some common uses for industrial IoT is smart manufacturing, connected assets and preventive and productive maintenance, smart power grid, smart cities, connected logistics, smart digital supply chains. Next technology is advanced robotics. Advanced and artificial intelligence, machine vision, sensors, motors, hydraulics, and materials will change the way products and services are delivered. A surge in technology talent for building, operating, and maintaining advanced robots will occur. Advanced robotic systems are ready to transform industrial operation. Compared with conventional robots, advanced robots have superior perception, interoperability, adaptability, and mobility. These improvements permit faster setup, commissioning, and reconfiguration, as well as more efficient and stable operations. The cost of the sophisticated equipment will decline as prices for sensors and computing power decrease. And as software increasingly replaces hardware as the primary driver of functionality. Taken together, these improvements mean that advanced robots will be able to perform many tasks more economically than the previous generation of automated systems. Producer, Producers are now deploying advanced robotics as an essential element of advanced automation that enables the self-controlled factory of the future. Enhancing plant structures and process with digital technologies can increase productivity and flexibility in both the, the factory and the supply chain, enabling producers to rapidly adjust to changing customer needs. The transformative power and advanced robotics. Software and hardware innovations enable the superior feature of advanced robotics, including the ability to process large data sets in the future, ancient human-machine interface and system technology. Mm. Industrial application of advanced robotic capability derived from advanced robotics enable new applications across factory operations. More than 40% of survey participants said advanced robotics are very important productivity driver today in production and logistics. And approximately 70% expect advanced robotics to become a very important productivity driver in production and logistics by 2025. Participants also expect to see significant productivity gains in equality and maintenance. Although individual companies will find different applications valuable. The following examples along the future chain illustrate potential opportunities. Production. Advanced robots are already present in production environments, and their importance will grow over the next few years. Discrete production, rather than continuous production, is likely to see the most favorable application of advanced robotics. For example, particular producer of sealing solution use more than 40 robots to load and unload machines in its manufacturing cells. Producers, especially in the automotive industry, also use advanced robots to autonomously process work piece or to perform assembly process. For instance, an automotive OEM uses robots to mount protective foils under pressure on the inside of car doors. Since advanced robots can self-adjust on the basis of environmental preparation, they can perform complex assembly processes such as those involving flexible parts. Direct real-time communication between workpiece and robots, for example, by using radio frequency identification technology, also support assembly. For example, robot can quickly change tools as needed without requiring explicit prior instruction. To facilitate another introducing robots into process, companies rely on simplified interface between robots and other equipment and on the ability to use existing information such as digital product data models to this is relevant process parameters. Next technology is biometric technology. So what is biometric technology? Biometric also a person to be identified and authenticated based on recognizable and variable data, unique and specific. Biometric authentication compresses data for the person's characteristic to that person biometric template to determine assembly. The reference model is first stored. The data stored is then compared to the person's biometric data to be authenticated. In this mode, its question is, are you indeed Mr. or Mrs. X? Biometric identification. Biometric identification consists of determining the identity of a person. The aim is to capture an item of biometric data from this person. It can be a photo of their face, a record of their voice, or an image of their fingerprint. This data is then compared to the biometric data of several other persons kept in a database. In this mode, the question is a simple one. Who are you? To know more about biometric system. Today, many applications make use of technology. What? Okay, next. Biometric identifiers. There are two types of biometric. First is physiological measurements. They can be either morphological or biological. Morphological identifiers mainly consist of fingerprints and hand shape, the finger fan pattern, and eye, iris or retina, and the face shape. For biological analysis, DNA, blood, saliva, or urine may be used by medical terms and police forensic. Second is behavioral measurements. The most common are voice recognition, signature dynamics, gesture dynamics, the way we use object, giant, and the sound of step, gesture, and others. The different techniques used are the object of ongoing research and development and are being improved continually. Physiological measurements are usually offering the benefit of remaining more stable throughout the life of an individual. For example, they are not subject to stress, in contrast to identification by behavioral measurements. next technology is 3D printing. 3D printing could enable unpredict then 3D printing could enable unprecedented levels of mass customization and dramatically reduce the cost of supply chain engineering and estimate economic impact of 230 dollars to $2030 billion to 150 billion dollars annually by 2025. So what is 3D printing? 3D printing or additive manufacturing is a process of making three-dimensional solid object from a digital file. The creation of a 3D printed object is achieved using additive process. In additive process, an object is created by laying down successive layers of material until the object is created. Each of these layers can be seen as a thinly sliced cross-section of the object. 3D printing is the opposite of subtractive manufacturing, which is counting out or hollowing out a piece of metal or plastic with, for instance, a milling machine. 3D printing enables you to produce complex shapes using less material than traditional manufacturing methods. How does 3D printing work? Let us start with 3D printing model. You can opt to create one from the ground up or download it from a 3D library. 3D software. There are many different software tools available, from industrial grade to open source. We often recommend beginners to start with Tinkercad. Tinkercad is free and works in your browser. You don't have to install it on your computer. Tinkercad offers beginner lessons and has a built-in feature to export your models as a printable file, simple STL or OBJ. Now that you have a printable file, the next step is to prepare it for your 3D printer. This is called stitching. Stitching basically means stitching up a 3D model into hundreds or thousands of layers and is done with stitching software. When your file is stitched, it's ready for your 3D printer. Feeding the file to your printer can be done via USB, SD, or Wi-Fi. Your sliced file is now ready to be 3D printed layer by layer. 3D printing industry. Adoption of 3D printing has reached critical mass as those who have yet to integrate additive manufacturing somewhere in their supply chain are now part of an ever-shrinking minority, where 3D printing was only suitable for prototyping and one of manufacturing in the earlier stage. It is now rapidly transforming into a production technology. Most of the current demand for 3D printing is industrial in nature. Human research and consulting forecasts in global 3D printing market to reach $40 1 billion by 2025. As it evolves, 3D printing technology is destined to transform almost every major industry and change the way we live, work, and play in the future. Next technology is genomics. Genetic engineering technology will grow with faster computer processing speed, DNA sequencing technology, and advanced analytic will improve agricultural production, reduce reliance on fossil fuels, and extend human life expectancy. And the last technology is blockchain. Blockchain is best known in the context of virtual currency Bitcoin, but a recent report showed 64 different use cases of blockchain across 200 companies. Streamlined, secure contacting and transacting will drive commercial use. So that's all 10 technology in 2025. Thanks for watching. Maybe sorry if any mistakes. See you in the next video. Last word. Assalamualaikum warahmatullahi wabarakatuh. Bye bye.